Our next speaker this afternoon is Dr. Margaret Race at the SETI Institute. Margaret is an astrobiologist at SETI, where she works on questions of planetary protection and forward and backward contamination. Margaret also has a long history working with NASA questions of public policy. Margaret?
Mm-hmm. Thank you, Rob. I wish, as we think about this topic, pretend, if you will, that I came before Chris. I think that I'll end up going through a lot of things that will inform you. Chris concentrated on two ethical discussions, one with second genesis, another one about life, and also talks about biological reversibility and that idea as a policy. What I want to do is talk to you about planetary protection and astrobiology as it links to solar system exploration. And I'll do that by taking a look at what planetary protection is and isn't, and there's some misunderstanding about that, where it comes from, and how over the years it's been translated from policy into regulations, who's involved in doing that, which Chris also mentioned a bit, and what current policies are and how and why they've changed over time. And then I'm going to show you, using case examples from Mars, how we take planetary protection policy and apply it to one-way missions, round-trip missions, and then in the future human missions, although we also did that in the past with the Apollo missions. And in doing that, we kind of bump into a lot of these problems. So I guess what I viewed in preparing this talk, I realized that planetary protection is nothing more than applied science and technology. Basically, what we're doing as a science community, as a spacefaring nation, is saying we think we want to be responsible in the way we explore, and we should do things about it in order to take care of these certain things, which have a scientific implication, have ethical implications. And so what planetary protection is the scientist's best guess on a good way to proceed. And it's put into policy and carried out. And it closed by taking a look at what are the underlying assumptions that we have somehow built into this system of planetary protection, and where are the ethical implications that we've bumped into that are literally part of planetary protection or also closely related to them. And then we'll look ahead and see what that means. So planetary protection could be conceived of as like environmental protection for the solar system. It traces back to the Outer Space Treaty of 1967 in Article 9 of the treaty. Says that spacefaring nations need to conduct exploration in a way that avoids harmful cross-contamination of the planets and also avoids contaminating Earth by introducing extraterrestrial materials. You'll notice there's a notion of protecting the planets, and it turns out all other celestial bodies, so it applies also to asteroids, moons, dusts even, all sorts of things that are out there that we might want to go and study. And it's really written in a way that preserves the opportunities for scientific exploration. So that's what Chris was meaning when he said that it preserves science. It was written at a time, so the discussion started in the late 50s, actually before Sputnik was even launched. Biologists recognized at the time that you could reach escape velocity and therefore send microbes off this planet to someplace else. And they began asking, is that a good thing to do? At the time also, there was a real push avoiding a militarization of space. So the fact that the scientists got the upper hand in the treaty is actually quite interesting, and that also happened in the Antarctic Treaty. So here we have two very pristine, wild places that now have treaties, Antarctic Treaty and Outer Space Treaty, both of which said they're resources for humankind, both of which said no planting flags and, oh, by the way, no militarization. So that's a hugely important step. So I don't want to sound too critical when I go back and now say, gee, it didn't think about environmental ethics. But nobody was thinking much about environmental ethics in the 50s and 60s, and that's something that sort of came about in our consciousness through the 70s and the 80s and into the 90s. So now when we're asking questions about environmental ethics and looking back to the treaty saying, gee, it's not in there with planetary protection, that is a fact, but it's still an incredible treaty, and the way we translate it is quite interesting. It's translated into practices. The international policy said thou shalt not have harmful cross-contamination, and harmful is up to anybody's definition. It's like saying thou shalt have clean air. Well, how clean? Fishable, swimmable for people, I mean, water pollution, air pollution, any of those, we set standards based on the best science that we have. And the standards may get looser or tighter depending on what we know. And it may even be redefined in the courts. For instance, think of recently with EPA being told by the court, now global warming is something you should consider. So there's reinterpretation. Those reinterpretations in the Outer Space Treaty and Planetary Protection are done by COSPAR, the Committee on Space Research, which is really a bunch of international scientists. And it's a standing committee of the International Council of Scientific Unions, and it reports into the United Nations. In its goals, the policy looks at two things: forward contamination, avoid taking microbes there, and contamination, don't bring them home accidentally or uncontained if that's appropriate. Now, also important to think about what's not covered by planetary protection. Near-Earth objects, definitely something we want to protect against, but that's really in an area called now planetary defense, and you've heard a lot about that. Planetary protection is about microbes, and so all of those problems about near-Earth objects, which have ethical implications, are not part of planetary protection. Likewise, nuclear issues. That surprises a lot of people. Whether we send heating units or power sources or nuclear reactors in space, whether there are issues of launch accidents or risk assessments, those are surrounding nuclear uses on in space exploration. Even flyby concerns, the Cassini mission when it was coming by Earth. That is not a planetary protection issue. That was an environmental health and safety issue on Earth, but not planetary protection. There is one part of planetary protection that does have nuclear implications, and that is to the extent that nuclear sources could become a perennial heat source and cause the melting of something, then you've got a spacecraft or parts going down into an environment and exposing microbes, or giving them a warmer, nice little, primordial soup to live in for a long time. Then it becomes a planetary protection issue. But in general, nuclear issues are not covered by planetary protection. Space debris, orbital debris, plenty of environmental and ethical concerns. And even jettison parts that impact the Earth, those are concerns and maybe have ethical dimensions, but not planetary protection. However, space debris at the end of a mission could have planetary protection implications. If we have a spacecraft orbiting Jupiter, as we had with the Galileo mission, the end of mission disposal of that craft was very important. We didn't want it to go on to, say, Europa. So at the end of the mission, where they put that spacecraft, how they let it deorbit into Jupiter, it turns out, had planetary protection implications, because we didn't want to send microbes, either accidentally or on purpose, into a place that might have life. Other things not covered by planetary protection yet include things like large-scale disruption of habitats, so what we're going to do on the Moon or Mars to build habitats, not covered explicitly, exploitation, commercialization, things like that. All the SETI activities, searching for extraterrestrial life out there that may be intelligent, not at all covered, because we're talking microbes again. And oversight for environmental impacts on Earth has nothing to do with planetary protection. So those are covered by other organizations on Earth.
Are you making your own conceptual definition, or is this one of planetary protection that exists in some kind of policy statement?
The latter. This is policy statement, how planetary protection is. It's microbes, it's in space exploration.
Could you amplify that on the last sentence of the previous chart? I didn't understand.
Oversight for environmental impacts on Earth. So for instance,
Of what?
anything about space exploration. So space exploration, launches, for instance, of materials, we don't ask whether there might be microbes that come back down on a spacecraft that we're launching to Mars or something. Anything that happens here on Earth, even, as I said, the flyby of the Cassini mission, and whether or not it might come in, that was a real concern to lots of people, but it was not a planetary protection concern under the Outer Space Treaty, Article 9. So planetary protection is very limited. And planetary protection plays out in the context of searches for extraterrestrial life and astrobiology, which Chris told you is sort of asking those fundamental questions: where do we come from? Are we alone in this universe? And what's the future in space? What we're doing as we do space exploration is looking for evidence of life. We don't have to find life. We could just find evidence of it, fossil remnants, footprints, you name it. Evidence of life would make everybody happy. We look any place we can, lots of different places, and we use whatever we can. We throw every trick in the scientific book and all of our tools towards it to see whether we can find things. Right now, searches for extraterrestrial life, which have lots of ethical underpinnings, an ethical look at ethics, are roughly three types. There's the SETI searches, the listening for signals out there, electromagnetic signals using telescopes, with the presumption that if you get a signal, it will be from an intelligent civilization. That's all indirect. It's like listening to someone, going home and picking up your phone and getting messages. You can tell a lot about the organisms. You can tell that they're there. I can't tell you about their physiology, their function, their intentions, or anything like that. All I can do is I can verify a signal. It's all indirect. I don't have to do anything about it. I don't even have to call them back. Likewise, searches for extrasolar or habitable planets is another area where we might think that there may be some ethical issues. That's done with telescopes out in the galaxy. It's another thing where we detect signals, maybe water. It may give us a hint of something biotic out there, but it's an indirect signal. We don't interact with it. If you'll notice, exobiology, that's in the solar system. We are here close. We are doing the same kinds of studies that we do on Earth. We're going there, we're poking, we're probing, we're using all sorts of geological, physical, biological tools to look at it. And it's made up of a number of different approaches. There's approaches that involve missions, as well as studying meteorites on Earth and all sorts of lab research on origin of life and impact experiments, or maybe going out into the detecting what's out there in the interstellar medium, the interplanetary spaces, and trying to understand how those organic building blocks could have then emerged in life. If you'll notice, among all of the exobiology, only missions is highlighted in red. And that's because that's the one place where planetary protection works. So until I started thinking about it in terms of what is planetary protection and what is it not, I didn't even come to this slide myself, that in all of the different searches that we have under astrobiology, only mission involves planetary protection. And that's the concerns about cross-contamination. So it doesn't mean we don't concern ourselves with environmental impacts here on Earth, but it's not NASA and it's not Coast Guard in planetary protection. So planetary protection focuses on life, it focuses on biological potential of environments, and it focuses on contamination during space missions. As Chris told you, we know that life exists on Earth. We know that life has three main ingredients, and Mars, for instance, has all of those ingredients, even presumably liquid water. The fact is, life can live in extreme environments here, so we know that life could live in places where the physical, chemical conditions and such are similar. So when we're looking at planetary protection concerns, we're focusing on microbial life or replicating entities. There could be other things that are biohazardous, but they don't fit in under planetary protection. We're just talking replication, so something potentially an ecosystem related impact, or something that might be infectious or of concern to people. It's all we can do is base it on life as we know it. We know a lot about biology, the characteristics of life, the limits to life, how it's adapted to environments, how it grows, reproduces, spreads, and we take that information from organisms that we know of on Earth in extreme environments and all the different places we've looked on Earth, and we look outside and say, is that environment like what we might expect on Mars or someplace else? And we're saying, if that target body we're going to could have life on it because of the being in similar ranges of conditions as we might expect life could survive, or if it did in the past, then we are interested in it for its biological potential. So when we're going someplace, we're looking to study the rocks and whether there may be remnants or fossil evidence, searching for things like liquid water or other clues, methane in the atmosphere, for instance, or something else that might be biologically of interest. And if we find it, the presumption is if you find it one place, it's essentially second genesis possibilities, and you probably have it lots of other places. So planetary protection, in my mind, is kind of the rules of the road for astrobiology. And we want to avoid past mistakes. Columbus, when he went, and the early explorers, when they went exploring, they didn't have like this. They didn't even know about the germ theory of disease. They did the best in their Judeo-Christian approach to things, but in going to the New World, they actually decimated human populations. More Native Americans were killed by the germs that were transferred, the cross-contamination of microbes, than by other actions that were done. So we don't want to do that again, and it stands to reason if you move around organisms on Earth from one place to another, you can cause ecological disruption or infection. So why wouldn't you be careful when you go to another planet? So planetary protection is our attempt to deal with that. It's an applied science. We're taking information about conceptual things that we know and saying, okay, how do we do it right when we go? And I think it's important to realize, too, it's more than just the knowledge. When Gregor Mendel was working with peas and figured out hereditary patterns on colors of flowers, information was interesting, and life went on. When Watson and Crick were working with the structure of DNA, really interesting, hugely significant information, and then life went on. And it wasn't until we started experimenting with genetic engineering and moving around organisms, we started doing and using that information. It wasn't until then that we started to talk about what's the policy, what are the ethical concerns. So too with astrobiology. We can think about whether there is life out there. We can examine it from afar. We can do lots of things. But once we start doing, now we are bumping into a place where we need policy. So planetary protection acknowledges that exploration has risks and there are possible impacts. And so these apply in the solar system. And we have to deal with that uncertainty about life. We don't know. So we've decided to take a very conservative approach from recommendations of the National Academy of Sciences. It's also supported from research we've done where we looked at public perception, and the public feels you should take that conservative approach as well. And that means we've got to have a policy that somehow applies during exploration when we don't know. We should have a policy or say something about what if we find life, what do we do upon discovery, and then what does that all mean for how we would go forward into the future. So think about planetary protection as doing that first thing, because what we don't know. We're at that point now, and so we do a policy that says planetary protection, all the planets, all the time. Every time we are talking about launching a mission in the solar system, planetary protection is sort of like a yellow light. We say, got to stop and think about it. Planetary protection categories exist now by target, body, and mission type. So if you look in the categories 1 through 5, category 1, saying if we know that there's no direct interest for understanding chemical evolution, if it's got nothing to do with understanding where life came from or how it might have originated, a place like the moon or Venus or even the sun, no planetary protection controls whatever. On the other hand, if you go down to the third category, Mars, and the fourth category, Mars again, if you're orbiting or landing Mars, you want much, much stricter controls because those are places with significant interest with respect studies of life and its chemical origin and evolution. So you can see even the policies are written in a way that favors science exploration. You'll notice category 5, which is Earth return. Sample return is category 5, but there's some categories that are no restrictions at all. If we know we're coming back from a place that has no biological potential, think the Genesis mission, the one that crashed recently, it was a collection of solar wind. No chances, the way it was caught in the aerojet, it had flash sterilization as it slowed down in the collection, but also there's no biological potential in the small particles that are being brought back. So there was no containment required. That's very different than if you go to a place like Mars and bring back samples, even small amounts of it, because Mars has biological potential. And we are moving things in very short order. Instead of taking thousands of years to travel around in space, we're moving things back in containment in very short order, a year or so. You had a question?
Just a point, Venus is actually a category 2 by COSPAR decision. Not
sure. Not sure about that, but okay, well, I'll look at it again. I've got the PrevCom book, okay. All right, so that's the policy itself, but then the planetary protection policies have not been fixed. What I like to think of them as a kind of like a leapfrog that goes from we have scientific ideas based on life as we know it. We have changes in technology that might suggest something else. We have missions that give us more information, and so then we might change the policies to reflect it. And there's a constant change. COSPAR has reviewed these, as Chris mentioned. They've changed over time, in part by working through with National Research Council recommendations. In the 60s to 70s, we just assumed that there was life on Mars. Probability was 1 that a terrestrial organism that might be shipped up there could live. So that's when the Viking bake the whole spacecraft approach was used. Then through 70s, 80s, 90s, there was the notion that, well, we've been there, we didn't find anything, it looks like it's too harsh to have life. So the probability of any terrestrial organism living up there on a spacecraft was deemed to be much, much lower than 1. So therefore we had a easing of the restrictions. Now we're in a transition period again with all of the recent missions suggesting there's now a greater probability of liquid water up there. We're getting more information about extremophiles on Earth. So the recent PrevGom report, it was a report on preventing the contamination, the forward contamination of Mars. It was published in 2006. And it focused on the fact that Mars isn't all a uniform planet. There are some regions that might have a higher probability of having water, liquid water, so being species. And since we don't know how to define where those are, we should treat the whole planet as a special region until we knew more scientifically. They also suggested the need to switch from the Viking era type of microbial detection methods, which have to do with culturing. Microbiologists now know that of all the microbes in the world, only about 1% are culturable. So if you cultured something and say, I didn't find anything, all it tells you is it didn't culture it in the right conditions. And you don't know for sure that there's nothing there. So we also need new sterilization methods for spacecraft. Spacecraft are different now with lots of plastics and such, and the equipment can't take the same kind of cooking that the Viking had. So right now we're in an area of transition where COSPAR and the space community is grappling with how do you change from the old standards for sterilization methods, the old standards for spores on numbers of microbes on a spacecraft, and how do you move to new methods that are molecular methods. The implementation for an individual mission, NASA implements COSPAR guidelines and policies and turns them into NASA requirements. Specific requirements for each mission are set by a planetary protection officer who is a biologist from Ames, actually. That office is also responsible for researching things like the methods and the sterilization and it reviews missions that. Every mission submits a letter to the Planetary Protection Office that says, what category do I fit in? They propose the category, talk about it, see where they fit, and based on that, then planetary protection requirements are proposed or handed out. And as you can see from that long list, there's not just one thing you do to meet planetary protection requirements. There's everything from clean room assembly to cleaning and reducing the bioload on individual pieces, making reassay it, certify all along, keep an inventory of what's on there, seal it up and prevent recontamination before launch, and even lots and lots of documentation on what you're going to do at the end of the mission. So there's a whole trail of things that are done for planetary protection. To give you an idea of how these apply to the different missions, going through the 3 kinds of missions we have right now, you'll see how we encounter the issues as we do essentially an environmental impact analysis. For one-way missions, for instance, Mars, contamination control is just the forward contamination control. We don't know if life is there, so we have to be careful. We have to protect the planet and the science because we just don't know. And the kinds of things that are emphasized are sterilization of the spacecraft on the way, cleaning, verification, and documentation of the microbial load. And yes, there are some microbes, dormant microbes, that are on the spacecraft, and those do meet the standards. We might trajectory bias so that the spacecraft goes planet, and until we know that it's going to be, that everything is okay, it is not tweaked that last bit to make sure that it lands properly, so that if there were a problem, it would go by the planet and not land on it. As I said, we sometimes can put on a bioshield to protect from recontamination and keep good information on what kind of microbes were on spacecraft when they were sent or when they crashed. Planning a round-trip mission gets more difficult and could take 10 years or so to plan. When we're talking about Mars sample return missions, launching and returning with just 500 grams of material, a 3-year round trip. It's all of the forward contamination controls plus back contamination. We want to make sure that when we bring things back, the concept is exotic species here on Earth. We don't want to contaminate Earth with organisms. And so those are environment, health, and safety concerns, not planetary protection. The science part, we want to have containment, as well as for making sure we don't leak out to the Earth. So that conservative approach traces back to the National Research Council study in '97 that says assume that anything you bring back is hazardous until proven otherwise through rigorous testing. And that includes the requirement of having to really understand what kind of test you're going to do. So there was a whole international community set of workshops that developed a protocol, and we do know how we're going to handle and test samples when they come back. The idea is we know already how to do it. If we had samples tomorrow, we could do it credibly, scientifically credibly, and legally. And it will only get better as equipment gets better as we go forward. But developing that protocol was a process of over a couple of years. We still have to build a sample receiving facility. There is none on Earth that does this combination of both negative pressure to control the microbes, pressure to avoid contamination of the materials. So we've got a unique set of engineering concerns ahead. And it will take probably 8 to 10 years to do that, starting from the design through impact statement processes and pre-testing to get it ready for when samples come back. And that doesn't include all of the environmental impact statements and launch approvals that might go along with a planetary protection plan. And this is, I found this one online at NASA Watch, and I love it because this is what we're trying to avoid. You don't think it'll be a problem. We want to avoid the uncontrolled release of organisms from another planet until we know that it's okay to do, like we do with the Apollo missions. So human missions to Mars we've talked about recently. The top left picture is a photograph of an astronaut, Apollo 14 astronaut on the surface and that of the moon, and the aura around is actually the cooling water, the vented cooling water. We know when humans are on the planet contaminate by the nature of the technology that they use and the nature of just breathing on each other and having 5 or 6 crew members up there on the planet for a couple of years. And when we brought people back from the Apollo years, they were put in containment and tested thoroughly for up to a total of 30 days of quarantine. We now know that if there were life on the moon, we would have it here on Earth. We did the best we could, but it wouldn't have been enough. So we've been trying to ask, could you have human missions to Mars in light of the fact that planetary protection exists? And how would you design that? The answer from a series of recent workshops is yes, you could go up with human missions, but the planetary protection policies, and there will be some, have to be developed. We're assuming that there will be some tolerable level of contamination allowed, say, around a landing. It means the need for a lot of precursor studies and science to understand Mars so we can identify zones where that background level of contamination would not swamp out any existing life. We assume that the surface might be one of those zones where it's so heavily irradiated and the environment is such that microbes could not live in it. So landing in an area and keeping it as a base area could be something that wouldn't be, quote, harmful cross-contamination to the planet. That would require certifying that the landing site has no extraterrestrial life on it. So all of this says precursor missions are very important. The crew would have to be isolated from the Martian surface and potential Martian materials during the duration. But that's what we do anyway when we go down in, say, the Alvin, or when we look at deep sea vents or other communities, or when Penny Boston goes into caves. So we have ways of dealing with that to minimize that contamination of areas that might be of special concern. The couple of workshops have dealt with some of the engineering issues. There are many, and they really fall into the categories of advanced life support, things like EVAs and mobility, and also waste disposal, another one that's really important, and monitoring and control. The issue of food was talked about before too. That's an interesting one. How do you know, how do you move from growing plants as an experiment to certifying it's okay to be a food. So we know that the moon could be a test bed for a lot of these long duration missions, and planetary protection should be included from the start and tested on the moon before we could possibly go to Mars. The Mars preparations for human missions would take some 20 years, and as I said, it's conceptually possible. Some of the real sticklers include the foods and supplies and all that bioregenerative life support. Things like waste disposal. Do you dispose of all of that human waste, water waste, whatever, on the surface? Do you bring it home? Do you jettison in space? These are policy decisions that have ethical implications as well. You have to make sure you're separating your astronauts from the space, from the areas of the lab, or also from those habitats where they're drilling down into environmentally sensitive areas. And you'd have to think about how you're going to quarantine people when they come home. Mission hardships are something that it's harder to get our hands on because it involves a lot of human factors. It's planetary protection gets involved because the humans are the walking contaminants, if you will. And there are also a lot of other things that are involved, the long duration and the inability to turn around, the muscle and bone loss, radiation and space debris, behavioral health problems from being in cramped spaces. To the extent that all these human factors are real, and they could have implications on planetary protection. If astronauts are unable, unwilling, or want to challenge planetary protection controls, that sort of complicates everything. So in planning for human missions, we bump into multiple levels of problems that are all based on science and all have policies associated with them. Protecting Mars as a planet because of its extraterrestrial life and environments, protecting astronaut health and safety, even including questions of if they're contaminated, do you bring them home? We get some really tricky questions. How would you what kind of monitoring do you do? What kind of things do you look for? And certainly protecting Earth when you come back. So when I think about framing all these issues, this is what I was talking about yesterday. Planetary protection is nothing more than science playing out in the real world. And we have to be prepared to examine the issues broadly and communicate with everybody. And it's going to play out in the news. Everything we do on missions like this will be real interesting to the public and scrutinized by the press. So we have to look at those places where basic science happens, and it's okay for the experts to be the ones designing missions and coming up with the proposals, because they're the ones that know how to deal with the technical expertise and the facts. And they have to deal with the uncertainties, and they are there, and they are interpreting data differently, and there will be debates back and forth. Likewise, then they're going to take that information about the science, is there life up there at the landing site or not, and make decisions. Yes, it's okay to land there or not. That's a planetary protection decision, but it's also then got an ethical implication for Mars. And then the societal implications of our going to a place or possibly transferring life between planets is something that are great too. So there's a whole host of questions that we've bumped into in doing planetary protection. They aren't necessarily part of planetary protection, but because we've considered the science behind it and the policies under the Outer Space Treaty, we've bumped into things that at the top level are those science questions, and then in the middle that have to do with the review and decision-making issues, and then we get into bumping into and having to answer through environmental impact statements and planetary protection documents, things that don't necessarily go right with those, things like ethical and religious questions, interfering with the evolution of life on Earth or elsewhere, playing God in what we're doing. And you can't answer those with the science information, but they're definitely part of the planetary protection dilemma. And then I had far-out questions. Up until recently, I called nudging questions, nudging comments as a far-out question. I think after the recent conferences, I don't know that it's that far out anymore, but people ask questions that you can't even answer. Are you going to upset the entire balance of the solar system by doing something? I don't know how you address those. So the big picture, when I think about planetary protection, it's broadly acknowledged as an okay way of doing things. In fact, 100 or so countries have signed the Outer Space Treaty, and it does seem to work as a good procedure. Space is viewed as a resource for humankind. Science takes precedence, and there's no militarization. Whether scientists should be the ones calling all the shots is for others to discuss. The current planetary protection policy is incremental. It's international in scope. And we have a pretty good way of addressing short-term questions during exploration. We are able to make adjustments that reflect changes in our understanding of science and technology. We've got it set so there's a period of biological exploration. We are saying each mission needs to make sure that it's doing things right. It won't crash, for instance, for the next 50 on the orbital ones. So we've got this notion that until we know for sure what it is life on Mars, be careful. And that's driven by the science, plain and simple. And the human policy, planetary protection policies, although they're not developed in detail yet, conceptually we've said we can go ahead. There's also a commitment to communicate openly with the scientific community and with the world at large about planetary protection. So in that way, it's a very interesting set of policy and decision making. But there are no planetary protection police. There's no enforcement. So it's just a matter of voluntary compliance among scientists. And here you have scientists being both the interpreters and the regulators at the same time and providing the oversight of what's going on. And I don't know how much of a problem that is, but it certainly is something to consider in terms of the ethics here. So if we look ahead, the issues that I think we've recognized through planetary protection are that scientists are the expert decision makers and the policy makers and the oversight. And the question would be, is that okay to continue? My own feeling is, yes, it is, but I'd like others to be involved. Planetary protection as it exists now focuses on governmental actions. Those are small-scale actions that involve missions, basically, that have small footprints in their impacts up there. That may not be the case in the future. Eventually, I think we'll have to take planetary protection and expand it like we have environmental considerations on Earth and think about broader actions like colonization, commercialization, tourism, landscape modification. So you could see a lot of places where planetary protection might expand with the biology behind it still, but implications for elsewhere. Right now, there are no policies at all about what we would do if we discover life. There is a SETI set of principles that say what we will do if we detect a signal. But for exobiology in the solar system, if we discovered life tomorrow with the rover, that's nice. We'd hear about it in the newspaper, and nobody's got any set policy. So the only place it's been addressed that I know of is in the draft protocol, and we did an entire session on what would we do if we discovered life in the glove box on. And it was taken strictly from a scientific and technical perspective. First thing you want to do is check the gaskets, make sure that the materials are holding, and then redo your protocol. So we went through it very much as a science issue, certainly with ethical thoughts in mind, but even the people that should get together and review it were deemed to be a scientific advisory committee. Although the group did recognize the importance of communicating broadly about the data as it was unfolding sample receiving facility, so that we would determine even at what point does it go from data to discovery. There's a lot of uncertainty. So they're thinking about how to deal with the public side of it, but we don't have it worked out beyond the science and technology. And everything that we've talked about so far in planetary protection is based on life as we know it. So what happens if we discover Chris's second genesis? How does it change all of these things? Space treaty and the ethical aspects covered under it are unclear or mute essentially on individuals, private sector, all of those other things we talked about today. And it is based on preserving science right now and is mute on environmental ethics about other planets like Mars. On that point, there's no explicit treatment of ET life or ET environments as to their rights or obligations or anything like that. And the recent National Research Council report on Mars urged that NASA should encourage and sponsor an international workshop beginning to look at these ethical issues and ask the question whether or not there needs to be a revisiting of the Outer Space Treaty to craft it in a way that blends ethics into it as well as science preservation. Others have written on the idea that maybe we even need a cosmocentric legal and ethical systems. All our legal systems, all of our ethical systems as are based on life as we know it. So if we discover something else, we have a whole area of policy and decision making that we don't know how to approach. And I think that with all of these things in mind, it's really important that we find a way to involve ethicists and others in the discussions in a formal way. And perhaps we can learn some of that by looking at things like the Human Genome Project, which has admitted that in genetic engineering and in going forward, we have the potential to do some very significant changes scientifically, evolutionarily, and ethically. And so now a certain amount of funding even is set aside so ethicists are a part of human genetic manipulations. And planetary protection, in dealing with all of these issues that started just with microbes on spacecraft, it's caused us to address long-term issues and really think differently about approach societal level questions, similar to the way that we have inadvertently through looking at genetic engineering or nuclear or industrialization or global warming. So I think in looking that way, I think planetary protection has caused us to stick our head up in a formal way because we're required through a policy and a treaty. And we have bumped into issues that are way bigger than just the microbes and have given us pause to think about a lot about exploration. So planetary protection is a very narrow niche, but it touches on so very much because it touches on life. And I'll be happy to take questions.
Thank you, Margaret. Wonderful talk.
Where's it coming from?
Full of ideas. I've actually
Oh, okay.
off-roaded UNT. I'd like to pick up on the point that you asked here in this last about ways to find, looking for finding a way to involve ethicists and the public. I'd like to encourage that. In fact, I have some ideas about how we might do this beyond this conference. But I'd like to also suggest that one of the points I made in my introductory remarks was that we need to expand our understanding beyond of the issues involved beyond ethics to more broadly speaking philosophical issues. And I think this topic raises this in spades. Kristen Schrader-Frechette joined us today, and she'll be here for tomorrow as well. And Kristen's done wonderful work over the last 15 years, working on, for one example, with questions concerning the disposal of high-level radioactive waste. And the contributions Kristen has made have certainly had a fundamental ethical component. But if I were to identify one area, it would be the philosophy of science, out of which grow political and ethical conclusions. And I think your own statement here of a few moments earlier, a slide where you said that scientists have been the expert decision makers on planetary protection, and you raised the point whether it should continue to be that way. I'd argue that for two reasons it should not. First, a political reason, that in a democratic society we need to bring in other voices. But second, for an epistemological reason. Epistemology is that branch of philosophy concerned with how do you know, what do you know, how do you know, how do you demonstrate what you know. Of course, scientists are epistemologists. That's what they spend their time trying to figure out. But philosophers of science are epistemologists as well. They approach these questions from a different perspective, possibly with different, I would say, different analytic tools and with a different historical perspective and different intellectual agenda. And so the kind of questions I think that a philosopher of science would bring to planetary protection would be things like, when you use the word conservative, taking a conservative approach, by what metric is this called conservative or liberal or moderate? Again, I'm struck by the fact that there is a laboratory model going on here about what is knowable about planetary protection. One of the great challenges within one of the great questions within the philosophy of science is the relationship between lab results and real world effects. You see this with the global climate change. It's one of the issues with GCMs, with global climatic models. You see this constantly throughout scientific experiment. How do you translate lab results to a real world environment where we don't get to control all the parameters and repeat over and over and over, in which each case is unique? So in summary, it's these kinds of skills that I think that philosophers of science, as well as ethicists or people who are epistemologists and others, that might be bring to the table to help us think about these really provocative problems.
I agree, and let me just say, I bumped into these issues when I was at University of California in the Office of the President. I was involved during the first deliberate outdoor release of a genetically engineered organism, and when the university system did its impact statement, questions came up in the impact statement that said, how do we know if this is an ethically right thing to do? I drew from my experience with genetic engineering as I came over to here, because to me they were just both problems that involved an exotic species, both really different and far out than compared to the mud snails I had studied, but they were no different conceptually. So I realized right away that I had to ask those kind of questions, those ethical questions, because all I could say in that impact statement is no amount of science information can answer that. And that's when I bumped into folks from Center for Theology and Natural Sciences and philosophers. You said one thing that I would like to follow up on, which is that you said we have a lot of questions. That's the only thing that I've got, is when you come in, I really appreciate the way you approach things, and those questions are making all of us sit back and think about things, but what we need is answers. And I don't know so if we don't make the answers from the lab model and interpretation of the data, and if the philosophers have lots of more questions and can well, the Native Americans think this versus the Buddhists or that and the Judeo-Christians. So we get lots of differences. Who's the one to make the decision? And I don't know. The scientist in me says, I want to just cede this set of questions to somebody else, but give me an answer because, oh, by the way, these guys are going to launch.
Well, that's an interesting point. There is a sense, there is a sense in which the philosophers are troublemakers. All they're going to do is make your job even more difficult. Of course, there's two of the responses to this. One is better safe than sorry, better to think about these things.
That's what the National Academy meant by conservative,
right.
Cautionary.
But secondly, you'll note that the title of this workshop tries to also at least put the problem you just mentioned on the table, because this is space science, environmental ethics and philosophy, and policy.
Yes.
And the point here is to try to bring the ethics and values, perspectives to the table in a policy way, to understand that we don't get to think about this for endless amounts of time, that the policy timeline may be days or weeks, and we need to give the best possible answer philosophically, scientifically, technically, economically, that we can.
Right. I know.
Great talk, Margaret.
Thank you.
When the Outer Space Treaty was created, the only entities that could get to space were government entities.
Right.
I'm listening to the groups that you're talking about participating in a revision of the Outer Space Treaty or some other group, and I'm listening to what Robert was talking about. And this is a different world now, because there are private businessmen and women that have the technology and the science and the engineering, and they're getting the money, and they can go to space and pretty much do what they want. And if they don't want to be subject to the Outer Space Treaty, they can find a sub-agency or a group to go launch out of Dubai or Singapore and not have the U.S. be responsible for them in a direct fashion. And I hear people talk about doing this all the time. To the degree that these new revisions are being done, there has to be an effort to bring in this business community to be part of the planning and part of the understanding. What's going to happen if you don't is they're not going to be part of the system and the solution. And maybe laws can get them to participate, but that's really different than being part of a solution.
Right, and that's why I think we need to have meetings like this. And the way I console myself on that, when I listened to your talk this morning, what I was hearing these people talk about the ethical implications towards their emerging industry, their new young industry. And that's a kind of selfish way of looking at it, because you want to make a preservation of an industry, and we're asking an Earth or a cosmos or something like that. And I just say, well, early on in any industry, there's lots of experimentation, and they're doing that in the context of our democracy and our commerce. At some point, if it gets big enough and private sector does things, I don't doubt that there's a lot of government agencies and lawyers that will get involved. And so they may not like it, but regulations will be there. And also, I have heard, I have never verified it from a lawyer, but I understand the nation signs a treaty, it becomes the law of the land. So like it or not, they too, as individual private sector entities, are subject to that. But you are right that they could go offshore, but this treaty has been signed by 100 or so different countries.
They're compelled to honor the terms of that treaty no matter where in the world they operate as an American citizen. But there are ways to operate outside of yourself with de facto entities elsewhere. But you don't want to get into that kind of a situation. You want to make them part of the solution. But yeah, it's one thing to have your lecture, which is outstanding, in this room. Come do it at a Space Frontier Foundation meeting where all these guys come. Show up in Phoenix at a Space Access Society where the Mojave crowd is there and watch the reaction. But put it in their face so they start getting the consciousness.
Tell me which ones to go to,
I mean,
because
I'm
I
really
kind of
serious.
like doing that.
I mean, I'm really serious. Go take it to them because they're not you.
We've had really good success going to the engineers, so International Conference on Environmental Systems or Habitation, the folks. And so, believe it or not, just reaching out to that community, the technology ones who are designing the missions, they never heard about planetary protection. They weren't aware that these are issues. But let me tell you that when you even get some of the geologists and astronomers on National Academy panels, they end up turning out to be some of the most conservative people, right? And so they will admit. You put it forward in logic and just say, now we have to make decisions, they'll agree that we should take a conservative or cautionary approach until we know more. Then go find me information, show me I shouldn't be caring about this because natural influx of stuff is so great that we've got these microbes here. Great, I can go down to category 1. So we've got the structure that we can adjust up or down, we just need more data.
I just want to make a point. I've got the microphone.
Okay.
I think if we some event or incident, either a contamination event or finding life in a glove box here or hearing life far away, and it's unambiguous and good signal to noise ratio, I think if it happened tomorrow, the decision would be jerked up to the White House of what to do, and you'd have a bunch of people that had never thought about it deciding what to do. And you know, they might call in the administrator who would say, I don't know, I haven't thought about it either. So I want to second and third what Bob and David have said, that I think you really need to start getting some people involved in this quickly and deeply so that when something happens, you have a track record and you have some citizens groups, which could be the Planetary Society, that already have some interest and some knowledge, and that you're not just getting a cold start on decision making.
Mm-hmm. Yeah. Yes, right.
Thanks for a wonderful talk. That you really laid out all the key issues so precisely and so well. I want to follow up on some of the things folks have said before, since you staked a claim on the thesis that the scientists should be making decisions, and then
They are.
Well,
Yeah,
okay, good. So it's a descriptive claim, not a normative one. Bob suggested that 2 reasons that we might not want just scientists making decisions are the democratic reason, which we all know since John Locke and Thomas Jefferson, it's our decision, scientists aren't unique. And then the epistemological one, you vary the people who give you the input, and you get more data, and you learn new methods and all that. There's a couple of other reasons to support Bob's point of view. First of all, scientists don't have any special expertise in value judgments.
Right.
That's why we don't make trial by jury trial by scientist and just ask the psychiatrist whether somebody actually murdered somebody. The second reason is scientists don't have property rights over the galaxy and the global commons. It's a commons, so decisions about it ought to be made by all of us. But now for the solution.
And them, and maybe them.
Yeah. Well, one solution, I think there are lots of solutions that exist. The Danes have been doing something for a couple of decades called consensus conferences, where they put together mainly lay people who are educated on issues by the scientists. And I say, you know, look at the IQs of most of the people you see in the Senate and the House, and you'll never doubt that you could educate some lay people to make these decisions. But the Danes have been doing this thing called consensus conferences for their science policy decisions, and they've worked really well. The U.S. equivalent of that is the this 1996 National Academy panel that I was on, and it's called Understanding Risk, and we proposed a model according to which Alvin Weinberg was right, that most of these issues are trans science. They're half ethics and they're half science. So what you need is equal weight from the scientific community and equal weight from the stakeholders. So that's what it proposed pretty straightforwardly. I don't know what you think, but.
I think it's, there's lots of different models, you know, and you could argue them. I think it's more important that we talk about them and try to, and we will probably be wrong in some of the things we do, but at least we're trying. And I think to defend the scientists, and they are caring, careful people who really throw themselves into these issues. And so I'm comfortable with what's been done, but I also agree that we need to have someone looking over the shoulder, just as we do on human genome or lots of other things. Okay.
Margaret, I'll return in a moment to this question of scientists' involvement in these ethical issues. I first had two rather elementary engineering-oriented questions. First with back contamination. And you pointed out correctly that the contamination following the Apollo missions was inadequate. Have we learned enough in the intervening years to be sure that we now have that problem in hand?
I believe so. In a nutshell, there was one meeting where we were talking about what would the containment be like. First of all, when coming back from a place like Mars, you're talking about bringing back 500 grams. It didn't fit in a coffee cup. So we're talking about this orbiting system that is contained.
No, I was referring to the returning Mars explorers.
Oh, the people?
Yes.
Oh. No, we haven't learned enough yet.
Okay,
No.
second.
No, we haven't.
That's right. I mean, we
Okay.
have,
For the containment of a sample, rock samples coming back, I think I feel pretty good about that.
okay. Second one, in terms of your notion of limiting the transfer of bacteria, or I'm sorry, of microbes from Earth to a limited area on Mars. Naively, I just think of those wild Martian winds
Good one. Good one.
carrying whatever you have, you know, around that latitude line. And
Chris McKay has a great one on that. You know how snow blowers blow things around? That's a great way. Those winds are fantastic because you take all those dust and put them up there, small particles, intense UV radiation, and you're sterilizing everything. So in a way, the dust are not a problem. The dust, in fact, the dust is something that probably keeps that surface sterilized the way it is. And so dust to your friend, perhaps, and we want to find
so
that.
it's not like having a no smoking section of the
Right.
restaurant. Yeah.
Right.
Okay. Then the third one, as I said, returning to your point about scientists making the ethical decisions. In fact, we've had a pretty terrible track record, haven't we? You know, from scientists during the Nazi period, doing clearly unethical things. We've all read the examples that are in the Belmont report about unethical activities in the past, and they continue to this day in terms of scientific fraud and so on. I don't think that, in fact, if anything, perhaps our own self-interest drives us away from being completely objective. On the other hand, when we look at decisions on teaching of creationism, I kind of think maybe a few more scientists would be helpful. Your opinion?
Scientists are people too. We got some good ones, and we got some. And the folks. What I see within the planetary protection community is, as I said, a really well-intentioned group of people, strong skills, who are trying to do the best job and do it the way it's required. And I can also, because I'm not NASA, I really have felt that if I didn't like what I saw, that I know how to talk about it to the press, and I would. But what I've seen instead is agencies coming in. So this is democracy the way it should work. An agency like NASA looking ahead, literally decades ahead, and asking these questions. Why am I being funded to ask these questions? They don't like what I'm doing, they could shut me up tomorrow. I'll go do fries and burgers or something. So I think we're in good shape. Do I agree that scientists have to have somebody over there looking over their shoulder? I think that's a good idea.
When you mentioned this point that we don't currently have a protocol for what to do if we, say, find some microbes on Mars or something, my first thought was like, well, why do we need a protocol? As far as communicating with the public, the discovery of the putative microfossils in ALH84-001 is perhaps a good example, and that worked pretty well. You have a big press conference, and you try to excite the public and milk it for all the funding you can get and everything. But that was my first thought, and then I thought, but actually, there were some people that knew about that for months before it was publicly announced, because they and everything, and then I thought, well, but what if that really was something as important as the real discovery of microbes on Mars? Is it ethical to sit on it? But there's a couple of issues there. One is that there are these perhaps stupid embargo rules for nature and science, and it seems to me clear that with something this important, that it would be unethical to follow those rules. I mean, I right now know some scientific results that I can't tell you in this room because of the nature embargo rules, but they're not that important, and so I feel okay about honoring that. If I violated that, I might lose my NASA funding, and that would stink for me, but it's not like I'm preventing the world from knowing something really important. But if I knew that we had discovered life on Mars and I wasn't telling everyone because of that rule, then I think it would be unethical of me to enforce that. But those people working like ALH84-001 and perhaps the people who discover life on Mars, at first, they won't be sure about what they have.
Right,
And there's
it's
a period
data
of time,
at one point, not information
right,
or
there's a period
facts.
of time when you're trying to, but where is the balance point between being careful and being responsible as far as transparency goes when we find something like that?
I would say, number one, that's not a planetary protection concern. That is an ethical dilemma that we've bumped into because of it. And so I would ask other people about that. We have rules about embargoes for reasons, yes, that's how it works. If we don't like it or think that that's a problem, we can change them. And I would say on something like, while it would be extremely significant scientifically, societally, ethically to discover life out there, I don't know that finding out Monday instead of Thursday would change where I shop for groceries. So I'm not bothered about it, and I don't think of it as a huge ethical dilemma of the sort like true cross-contamination. It just shows you that planetary protection has brought me into bumping into issues that I never even thought about before. And I know that as a scientist, I can't address them. So, thank you. Thanks.